Imagine floating above Earth's icy poles, staring down at a dazzling white wilderness no human has ever seen from space before. Sounds thrilling, right? That's exactly what the Fram2 crew did on their historic mission in March 2025. Launched by SpaceX, this team of 4 private astronauts, Chun Wang, Janaki Mikkelsen, Rabea Roshi, and Eric Phillips, became the first humans to orbit over Earth's north and south poles. But this wasn't just a joyride. Let's dive into the risks, the science, and the stunning views that made Fram2 a mission for the history books. What makes polar orbits so special? Most space missions stick to orbits closer to the equator, like the International Space Station's path at a 51.6-degree inclination. Why? It's easier and cheaper. Earth's rotation gives rockets a speed boost when they launch eastward, saving fuel. But polar orbits, which fly straight over the north and south poles at a 90-degree inclination, don't get that boost. They require more power, making them trickier and more expensive. Until Fram2, no human mission had taken this path. Named after a Norwegian ship that explored the polar regions in the 1800s, Fram2 aimed to break new ground. And it did, but not without risks. The crew. The Fram2 crew wasn't your typical bunch of astronauts. They were polar explorers turned space pioneers, and their resumes looked nothing like NASA's usual lineup. Chun Wang, a cryptocurrency mogul from Malta, bankrolled and led the mission. Norwegian filmmaker Jannika Mikkelsen took the role of vehicle commander. German robotics researcher Rabea Roga became the pilot. Australian adventurer and polar legend Eric Phillips served as medical officer. Not one of them had been to space before, but each had stared down the lethal cold of the Arctic and Antarctic, making them perfectly suited for this bold leap into the unknown. They first crossed paths on the icy outpost of Svalbard, bonded by a shared obsession with polar frontiers, and now they were about to confront dangers most astronauts never have to face. Danger number 1: radiation in the polar skies. Unlike equatorial orbits, their polar path sliced through the Van Allen radiation belts, Earth's invisible minefield of high-energy charged particles. These particles can fry electronics and damage human cells. RAND space safety expert Jan Osberg warned that Fram2's crew faced a harsher radiation dose than standard missions. 4 days might keep exposure low, but one system failure could turn a science experiment into a medical emergency. SpaceX hardened Crew Dragon systems to survive the bombardment. Yet for future missions, like Mars, Fram2's data could be the difference between survival and catastrophe. Danger number 2: no safe haven. Most astronauts can retreat to the International Space Station if disaster strikes. Fram2 couldn't. The ISS orbits at a different tilt, and their Crew Dragon Resilience had a cupola window instead of an airlock. Beautiful for views, useless for docking. A capsule failure might have forced them into a spacewalk in SpaceX's new EVA suits, assuming they even had them on board. It was a one-way gamble: fix it themselves or face the void. Danger number 3: the tricky dogleg maneuver. Launching into polar orbit from Florida's Kennedy Space Center meant the Falcon 9 couldn't just blast straight north. It had to veer sharply mid-ascent to avoid populated areas like Florida's Gold Coast. That sharp turn burns extra fuel, eating into payload capacity and tightening the margin for error. SpaceX had pulled it off before with satellites, but never with people. One miscalculation could have ended the mission before it began. Yet on March 31st, 2025 at 9:46 p.m. EDT, the Falcon 9 carved the turn perfectly, sent Fram2 into history, and nailed a first-stage landing on a drone ship. Space sickness and microgravity mayhem. Once in orbit, the Fram2 crew hit an unexpected wall: space motion sickness. Within hours, all 4 were nauseous, even vomiting. Chun Wang described it as unlike any motion sickness on Earth. Even a sip of water could trigger it. Day 1's grand window opening plans were scrapped. By day 2, they recovered, savoring breakfast with a South Pole view, a reminder that even elite explorers can struggle in space's alien environment. Stunning views. The Fram2 crew's photos and videos left the world in awe. From 460 kilometers up, Antarctica looked pure white, with no signs of human activity, Chun Wang noted. Jannika Mikkelsen was surprised to see her home, Svalbard, looking unfamiliar from space. "It took a few seconds to realize it was Svalbard," she said, noting how the view differed from maps. The crew also captured rare phenomena like Steve, strong thermal emission velocity enhancement, a glowing purple and green light display similar to auroras. Science in the stars. Fram2 wasn't just about sightseeing. The crew conducted 22 experiments, from growing oyster mushrooms in microgravity to taking the first X-ray images in space. One study, led by Saudi Arabia's Falak for Space Science and Research, explored how microgravity affects the eye's microbiome, looking at bacterial behavior and antibiotic resistance. Another experiment tested human cognition in space's early hours, helping understand how astronauts adapt. They even connected with ham radio enthusiasts for a competition called Fram2 Ham, sharing scrambled images from orbit. A new kind of splashdown. After nearly 4 days, Fram2 ended with a splashdown in the Pacific Ocean on April 4, 2025, the first for a SpaceX crewed mission. Usually, Dragon capsules land off Florida's coast, but SpaceX is shifting recoveries to the West Coast to reduce the risk of debris hitting populated areas. The crew exited the capsule without help, testing how spaceflight affects their ability to move after landing. Jannike Mikkelsen was shocked at how heavy her body felt after just a few days in microgravity. "My body had forgotten gravity," she said. This experiment could inform how future astronauts recover after long missions. Why polar orbits matter. Fram2 wasn't just a stunt, it pushed the boundaries of human spaceflight. Polar orbits are common for satellites, but humans had never taken this path before. The mission's 90-degree inclination beat the previous record set by the Soviet Vostok 6 mission in 1963, which reached 65 degrees. By flying over the poles, Fram2 gathered unique data on Earth's remote regions and tested human endurance in a harsh orbital environment. While some scientists, like Bled Bowen from Durham University, called the mission run-of-the-mill scientifically, others see it as a bold step toward routine space travel. The human side of space. Beyond the dangers in science, Fram2 was a human story. The crew bonded over a movie night, watching their own launch to fight motion sickness. They FaceTimed Elon Musk via Starlink, tested high-speed internet in orbit, and chatted with the students and families. Eric Phillips described the joy of floating in microgravity. "It's amazing in videos, but it doesn't reflect the joy it brings." Chun Wang even waved to Svalbard from orbit, fulfilling a promise to his friends below. What's next for polar orbits? Fram showed that polar orbits are possible for humans, but the risks, radiation, isolation, and complex launches mean they'll remain rare for now. Still, the mission's success could inspire more private spaceflights. Chun Wang hasn't committed to another mission, but the crew expressed excitement about flying on SpaceX's Starship one day. As space travel becomes more common, polar orbits could unlock new ways to study Earth and prepare for deep space missions. In conclusion, Fram2's polar orbit wasn't just a spaceflight, it was a daring dance with danger. Battling radiation, isolation, and perilous maneuvers, the crew uncovered stunning polar vistas and rare X-ray data. Their courage proves the riskiest journeys often reveal humanity's brightest horizons. If you like this video, hit the bell, leave a comment, and thanks so much for watching.